Okay, we're in section 19 of the notes, and we're dealing with rational exponents. So we covered the material. We talked about the rules as they pertain to integer exponents, but now our exponents are going to be rational, all right? Now, rational means a ratio of integer. So that doesn't preclude the possibility they can't be integers still. But the deal about this, if you remember that we've studied this before, but in the past we really didn't use rules except for those rules about the negative powers. Right now I'm getting more comfortable with exponents, and I want to say that the rules are starting to make more sense to me. So it's going to be like a rule-based system somewhat. We certainly went through the meaning of a fractional exponent, and then we went through examples, all right? The examples we went through hopefully have been studied and well understood at this point. And what you have to do now is reinforce what we presented to you, and that's by doing the homework. Again, the hope is that you've done the homework, you studied the material, and you feel comfortable with it. So I'm going to switch to the whiteboard. And as I do that, you should have the notes and your homework in hand at this point to sort of like verify that what you're doing is correct. Okay, let me get my whiteboard out. And give me a second here. Okay, you're seeing the whiteboard now. And whoops, I just dismissed something I shouldn't dismiss. Give me 1 second. I just closed my notes. I got to reopen them. Okay, we're in section 19. Of the notes. These are class notes, and we're doing the homework. Start with number 1. What does it say? Rewrite the exponential expression. Well, this is 3 to the 1/3 power. And what they want me to do is write as radical notation. Radical notation is going to look like this. I want to point out that let me point this out to you. This 3 over here is going to be put on the inside. And now the index, I point this out to you, is going to be 3. So that goes right over here. How's it read? The cube root of 3. Right? That's all they asked me to do. Look at the answer key, and you'll be staring at that. All right, let's go to number 2. What do I have here? 5 to the 1/2 power. What do they want me to do? Rewrite it as a radical. I'll do that. I'm going to point this out to you. This 5 goes on the inside. That's called a radicand. And the index, I'll point this out to you, is 2. That goes right here. I'll put that down for you. Now, I'll be honest with you. Most people don't put the 2 there. They just write this down instead. We would actually prefer that. That's what your calculator does as well. How's that read? The square root of 5. Let's go to number 3. And number 3, I'll write this down for you, says rewrite this, and this is 2 to the 3/5, and then we'll write as radical. There's several ways to do it. I want to go through in steps for the most part, and I know it's difficult, but what I want to put down is that this is 2 to the 1/5 cubed, or you could write down 2 cubed to the 1/5. All right. Now, I'm going to focus on them separately. And someone says, why would you do that? The deal about this one is they're really kind of easy to do. It's going to be a radical notation. I'm doing the one on the left first. The index is 5. Right? Then when you get on the inside, 2 cubed, which would be 8. I want to point out the one in the middle could also be written as the 5th root of 2 whole thing cubed. I'm going to be honest with you. Looking at that one there, I don't think it looks too good. So I'm going to go with the one on the end that's in the box. And what's that going to be? The 5th root of 8. And that's done. All right. All right, let's keep going. Go to number 4. And what's number 4? Ooh, this one looks interesting. And what do you have over here? 64 over 27 to the minus 2/3. All right, I got troubles immediately. I got negative power. And I'm not saying negative power is a real big trouble, but I would certainly like to write it as a positive power because maybe I'll be able to understand it better that way. So what's it going to be? Well, 2/3, and what goes on the inside now? The reciprocal. We've done this in the past. What do they want? They want 2 of the 3 equal factors. And repeat what I said. They want 2 of the 3 equal factors of that number. Well, it'd be nice to know that, right? Well, 27 is 3, 3, 3. 3 times 3 is 3. 3 times 3, 3 times 3 is 9, times 3 is 27. The bottom is 4 times 4 times 4. Again, I want to outline what they're asking for. They're asking for 2 of the 3 equal factors. Well, this would be 2 of the 3 equal factors. What would that give me? 9/16. Again, we're trying to get the understanding of what a fractional exponent is giving us. All right, now someone says, if I wrote it in radical notation, could have done it? You could. Still the same answer. I don't think radical notation really adds much to the problem, though. Let's keep going. And go to number 5. And number 5 is x times x to the minus 1/3. Well, what I'm going to do over here is talk about rules here. A to the n times a to the m is equal to a n plus m. I'm going to write that as an exponent, and I'm going to put this down now as a rule-based system. What's it going to be? 1 plus minus 1/3. What's that going to give me? X to the 2/3. Look at the answer key, and you should be staring at that. Let's go to number 6. X to the 1/4, x to the 3/4. We're using this rule over here. So a to the n over a to the m is a to the n minus m. Let's write that down. And what would that give me? X, 1/4 minus 3/4 is minus 2/4. And minus 2/4 is minus 1/2. Now I got to be honest with you. I'm not offended by negative exponents. However, at the school, they want you to write this as a positive exponent right now. Both answers are good for me, though. Let's look at the answer key, see if we're staring at it, and I'm seeing it. All right, let's keep going. And I'll do number 7 now. Oops. And what do I see for 7? X to the minus 4/7 over x to the minus 2/7. Well, I get the same rule. Minus a minus would be plus 2/7, right? So what do you get there? X minus 2/7 now, right? Because minus 4 plus 2 is minus 2. And again, I don't mind a negative power, but I'll write this with a positive power now. If I'm putting a box on something, I'm saying it's an acceptable final answer, by the way. Let's look at the answer key, and I'm seeing it. Oh, that's good news. Let's keep going. Number 8, we're just reviewing the rules. And number 8 is x to the minus 5/6 raised to the power minus 18. I'm going to recommend the rule we're going to use over here. A to the n raised to the nth power is a to the n times m. Well, it doesn't look too bad. X to the minus 5/6 times minus 18 now. What would that give you? Well, it can be a positive number, certainly. That'd be 15. Look at the key. We're staring at it. Go to number 9. And what do you get over here? X to the 4/5 times y to the 3/10 to the 10th power. Well, I'm certainly getting better at this. I know it's a multiplication exponent. So 4/5 times 10 is going to be x to the 8th then. 3/10 times 10 is 3. Go to the answer key. Make sure you're staring at that. Again, I want to point out, if you're not staring at that, there has to be something wrong somewhere. Let's go to number 10. And number 10 looks like it's a long problem. Well, I'm going to work on the inside first. And what would you get over there? Well, I'll write on the side. Minus 7/6 minus a minus 5/6 is minus 2/6. All right, going to use my exponent rules. What do you get over here? 1/2 times minus 6 is minus 3. And minus 2/6 times minus 6 is going to be y squared. I don't mind that answer. But again, I want to point out Essex, they want you to write as positive powers. Look at the answer key, see if you've got that, or they have. Both answers are listed. All right, can go to Sage. Just briefly, this is kind of a short section here, not much to say about it. Just reaffirming the rules of exponents. They apply to any real number, actually. We've discussed the integers a while ago, and now we're doing the ratio of integers to rationals. Well, let me switch over. And I'm going to go to Sage. All right, so we're in the notes now. Again, we're going to do CoCalc. This should be very familiar to you at this point. I want a new worksheet. I'm going to do a Sage worksheet. Just give it a second to load. There you go. Reset. We've been doing this for a while. Remember shift return. X is a variable. Seems like we've been doing this forever now, huh? Shift return. 64. Raised to a power. What power? 2/3. 16. I guess we could have done that by hand, right? And again, you could go through the other problems if you want by typing that stuff in there. And again, what you're just typing is what we see over here. You can also do copy paste. For example, let's say I want to do this one over here. Yes, this is coming from the notes. I just copied, pasted. Remember, shift return gives me the answer x to the 4th power. Okay, good luck.